And actually, one of the attendees of CMSC is actually going to be one of our guests here on the show in just 1 minute. And you know, we've spent a fair amount of time covering 3D measuring devices on the show, but one we haven't covered is probably the most ubiquitous of all portable 3D measuring devices, and I'm talking about the portable measuring arm. You see one right there. You've probably seen these or used these. They're also called portable CMMs. And here to give us a brief overview of what a portable arm is Chad Crisostomo of Faro. Hello, Chad. How are you doing this morning? Uh-oh. Audio?
Well, we don't have Chad's audio up. But
1 second. We got it? Hey, Chad.
Hey, Dirk, can you hear me now?
Awesome. Okay, there we go. Okay, so let's just get started right into it. We saw a picture of a portable measuring arm. Why don't you just tell us briefly what it is?
Well, a portable measuring arm is essentially a coordinate measuring machine that's shaped like a human arm that can measure features in 3D space, either with a hard probe or with a handheld laser scanner. And depending on which model you get, they can measure parts up to 12 feet long.
And what does it replace? I mean, before you had a portable arm, what would you have done?
Well, basically any hand tool that you would find in a typical quality lab used for measuring, such as calipers, height gauges, micrometers, even tape measures. And also because they're lightweight and portable, they also replace fixed CMM beds.
Okay, so let's talk about the fixed CMM. I mean, a lot of people are familiar with a fixed CMM. You typically find them in a controlled environment very often. You know, yes. a calibration lab or your own metrology lab. They tend to be very accurate. How does an arm compare to a CMM? Can it replace a CMM, or it does sometimes? Or tell us a little bit about that.
Okay, well, because a fixed CMM is in a controlled environment, it doesn't offer the flexibility that a portable CMM does. With the portable CMM arm, you can actually take it to your part, and you don't have to bring it to a controlled environment. It's a lot cheaper than CMM beds as well. For most applications that you see in the industry, the arm works great for. If you have very high accurate measurements, then you would still require a CMM bed.
Okay, and what about fixturing? I mean, again, with a CMM, if people have used a CMM, they're used to having to fixture a part. Is that a case also with an arm?
With the arm, it's great. Once again, it's portable. You can take it to a fixture. You can, measure features on the fixture and get instant feedback without having to wait for a CMM bed to do all the measurements for you.
Okay. Now, let's talk about, I mean, arms have been around, I don't know, how long have they been around? 15 years, 20 years?
Yeah, since the start of 2000s.
Okay. So how have they changed over the years? Are they more accurate, more insensitive to temperature variation out on the shop floor, that sort of thing?
They've definitely come a long way as far as temperature compensation. Essentially, to put the accuracy in perspective, in the early 2000s, the arms we were building were roughly measuring around 2 to 7 thou. These days, we're able to capture point data that's repeatable to less than a thousandth of an inch.
Wow, that's quite a bit of increase. Mm-hmm. What about volume? What about measuring volume? How big a size can they measure?
Like I mentioned earlier, anywhere from 4 feet in range or smaller to all the way to 12 feet.
And that's from a fixed location, right? Now, if I understand, if I remember this right, is it possible to, I don't know, leapfrog, or I mean, can you extend that volume in any way by referencing one set of measurements to another set of measurements and increase your volume?
Absolutely. Some software is called move device position. In the industry, it's called leapfrogging. Like you said, you measure some features that are in common with another position, and then you can move the arm. Generally, you want to keep the arm in one position because that you'll get the most accurate results. But when you do a leapfrog, you do incur a little bit of error. So that's why some people just get a bigger arm.
Okay. Now let's talk a little bit now about about software. I mean, obviously you have an ARM, you've got to collect this data, it's got to go somewhere, you've got to do something with it. Talk to us a little bit about how software plays into this.
Software plays a big role. Just because you capture the information, that's getting easier to do with hardware. It's always easier to capture information, but the next step is to process that data. So software is playing a big role. You have tons of 3D point cloud softwares out these days, and they're just making it easier and easier to process the data. We're talking about making anywhere from CAD-based inspection, where you're comparing your data that you captured to a CAD model, all the way to just comparing to blueprints or even reverse engineering.
Okay, and let's also cover probe types. Now, I think you mentioned right at the top that you can have a hard probe, or you can have a scanning probe. Can you interchange those within a within one? I'm not sure what you would call it. One measurement routine.
Session.
Okay, yeah.
Yeah, oh, absolutely. You can toggle in between all kinds of probes, hard probes. You can do touch probes, laser line probes, like you said, and you can do that all within one session.
So Chad, we have a webinar coming up this Tuesday, the 16th, where we're going to be talking about these technologies and talking about the Faro arm as well as combining it with Polyworks.
Right.
In metric. So tell us a little bit more about what we're going to really see and hear, and what the viewers out there who may want to register, and you can register right below the web page right there. People who may want to register for the webinar can find out about about these two technologies.
Essentially, we'll be talking about the technology of the ARM, what it can do. You'll also get a live demo of Inometric Polyworks, Polyworks Inspector, that is. You'll be able to see a CAD-based inspection, as well as a little bit of reverse engineering.
Okay, and that's called the name of that webinar, and I think the link is below the player page there, is Dynamic Duo Quality Inspection with Faro and Polyworks Inspector. That's going to be Tuesday, July 16th at 11 a.m. Pacific, 2 p.m. Eastern. So be sure, if you want to get more information on that, click on that link down below. Chad, thanks for joining us.
Absolutely. I'll see you guys at CMSC.
Oh, yeah, that's right. We'll see you at CMSC. Thanks, man.
See you in San Diego.
All right.
And